In this lecture, we will see that how we can apply the wind load to our residential building. Okay, so in order to do that, first of all, you have to go to define. Okay, after that, click on load pattern, and from here, you can see here that right now we don't have any wind load. So I will just simply go here and type here wind load. Okay, after that, the type will be wind. Okay, and from here I will choose the auto lateral load as Indian IS code 1875 2015. Okay, and after that I will just simply click on add new load. Now that we have added this wind load as per IS code, we need to modify it. So in order to do that, first of all we need to just simply click on modify lateral load, and from here you will get these windows. Okay, so now you can see here that the exposure and pressure coefficient is selected as exposure from the extent of diaphragm. Okay, so right now we have not defined any kind of diaphragm, so don't worry about that. We are going to define the diaphragm in the next lecture. Okay, first of all let's try to understand that what exactly it is saying. Okay, so you can see here that here we have to provide these information, that is what is windward coefficient, what is leeward coefficient, what is wind coefficient, what is wind basic speed, terrain category, and all these things we have to provide here. So if you don't know how to provide that, let's look at the PPT. Okay, so here you can see that this is the map of the India where the basic wind speed is given. Okay, and I am taking my residential building in these regions, or you can say in these yellow regions. So I will take the basic wind speed as 39. In your case, your residential building might depend might get situated in any of these regions, so like that you have to take the value. Okay, so now that we have understand this thing, so first of all let's enter the basic wind speed as 39. So this will be 39. Okay, now if you look here, you will see that we have to enter the risk coefficient for different classes of structure and different wind speed. So you can see here that I'm going to assume that my building will be the mean probable design life of the structure is taken. I will take that at 50, and from here you have to enter the K1 factor, and for 39 the K1 factor is 1. So if you look here at the K1 factor, you can see that this is the risk coefficient, that is the K1 factor, and we have entered the value is already 1. Okay, now if you look at the topography factor, that is K3 factor. Okay, you will see that the full for the topography factor K3. Okay, so if you can easily see here that I have taken the upwind slope as less than 3 degrees. So for that the value of K3 is 1. So you can see here that the value of K3 is already 1, and the importance factor we have already taken that as 1. Okay, so now let's go ahead and see more stuffs from there, and from here you can also choose the terrain category. So I will take that terrain category as 2. Okay, so you can get all these value from the IS code, but the problem is that how to deal with this wind exposure parameters, how to get the windward coefficient, how to get the leeward coefficient. Okay, so let's see that. Okay, so if you look here at this area, that is area of the face, first of all you have to find the area of the face, and then you have to find the area of the opening. Okay, and after that you have to take the percentage, and that percentage will come around 14.78. or generally, if you don't know all these things, what is the area, what is the opening, and all these things, you have to consider it as the partially enclosed. So in partially enclosed, in enclosed, what happen is that the area of this opening is less than 5%. In partially enclosed, the area is between more than 5% and up to 20%, and in the open you have the area is more than area of the opening is more than 20%. Okay, so right now we have to deal with this partially enclosed. Okay, Now if you look at here, okay, this sheet is from the IS code, and here if you look here that the height of the building is 12.3 meter, the building length is 11, the building width is 6 meter. Okay, so this is the information that you can easily get from your AutoCAD file or with the help of the ETABS. Okay, so after that what you have to do, you have to find the height by width ratio, and if you can see here that height is 12.3, you have to divide it by 6, and after that you will get this value as 2.05. And after that you have to find the L by W ratio, that will be 11 divided by 6, that will be equal to 1.83. So what you have to do is, first of all you have to use this H by W ratio, and from here you have to look into these that where exactly each H by W is fitting. Okay, so you can see here that H by W is equal to 2.05, so it is greater than 3 by 2 H by W and less than 6. Okay, so we have to either look into this one or either this one. Okay, so for that we have to look at the L by W ratio, and if you look here you will see that it is around 1.83. okay, so if this is 1.83, then you have to look in this region. Okay, because this is 1.5 and this is 4, so you have to look in this region. Okay, so let me, okay, okay, so now you don't need to look on this one, you have to only focus on these regions. Okay, just forget about this one, you have to only focus on this region. Okay, so now that we have understand this thing, what you have to do is let's go to the next slide. Okay, so before that I would like to show you something, that this ABCD, what exactly is that. So if you look here at A and B, you will see that this is the 0-degree phase, and C and D, this is the 90-degree phase. Okay, so now that we have understand this thing, let's go ahead to the next slide. So if you look here, you will see that this is the windward coefficient, windward side A, leeward side B, windward side C, and leeward side D. Okay, so from here you can see that these are the values. You don't need to deal with these values, you have to only deal with these values, because our value is coming somewhere around this one. Okay, so if you look here at A, that is A, this is A, this is the A, this is B. Okay, so these are the 0-degree angles, so you have to only focus only in this one. So this is A. If you look here at A, this is the windward side. Okay, so this is the windward side and this is the leeward side. Okay, so now that we have understand this thing, we just simply need to provide the values from here. So if you look at the leeward side at A, that is equal to plus 0.70, and this is minus 0.4. so let's go ahead and change this to 70, and this will be minus 40. This is very easy. Okay, now this is C and D. So C and D, for that you have to focus in these two. Why? Because this is 90-degree and this CHD is also at the 90-degree, so you have to focus in these two. Okay, so here you can clearly see that the value of this one is, so you can see here that at C this is plus 0.8. so let's go to next slide, and so it is already plus 0.8, and on the leeward side it is minus 0.1. okay, so let's change this to minus 0.1. okay, so now that we have understand these things, what you have to do is you have to find the windward side A. So this is the net coefficient pressure, and this is the value of CP. Okay, so here what you have to do is you just simply need to also, okay, so this will be 0.70. okay, and after adding that you will get this value as 1.2. okay, and this one is minus, so we have the here as minus 0.40, and after adding that you will get this value as minus 0.45. okay, and after that you have to deal with this one, and that will be point. So if you look at the windward side A, we are getting this value as plus 0.80, and this is the after doing this one. So you can see here that this is CPI, and CPI you can see here that CPI is plus or negative both. Okay, that's why we are taking a plus here and negative here, and after that plus here and negative here. But this is fine. And after that, if you look at the leeward side, you have to take this value as minus 1.10. So okay, and after that you will get this value as 1.5. okay, so now you can see here that we have successfully understand this part as well. okay, so after that, if you go to the A tab, you can see here that we have to enter only one windward coefficient and one leeward coefficient. So we have to either enter this A for windward and A or C, or leeward for B and D. So what I will do is I will take the maximum value. So for windward side C, windward, the maximum value is 1.30. So for windward the maximum value is 1.30. okay, and for leeward coefficient the maximum value is minus 0.45. so you just simply need to enter the value. You do need to either plus or minus sign here. okay, so after that, understanding all this calculation on all these things, you just simply need to click on OK. After that you have to click on OK. So this is how you have to deal with the wind load.